You know, in the world of Linux, being efficient with your files is everything. Today, we're going to dive into one of the most powerful tools for the job, file links. They might seem a little tricky at first, but trust me, by the end of this, you'll see just how much they can simplify your life.
Okay, let's kick things off with a situation I'm sure you've run into. You've got this important file and you need it in two different directories. So what do? I mean, the first thought is just to copy it, right? But now you've got two separate files, which weighs space and becomes a nightmare to keep in sync. There is a much smarter way, and that's exactly what links are all about.
But before we can really get how links work, we have to pull back the curtain and talk about the secret identity of every single file on your system. And that secret is something called an inode.
So what is an inode? Well, think of it like a file's social security number. It's this unique entry in the file system's master list, and it holds all the critical info, like who owns the file, permissions, and most importantly, where the actual data lives on the hard drive. The file name you see, like report.txt, that's just a convenient human-readable label pointing to the inode.
As you can see right here, the relationship is pretty straightforward. The file name points to the inode, and the inode points to the data. This is the key concept you have to get. The file name isn't the file itself. The inode is the file's true identity.
All right, with that foundation laid, let's jump into our first type of link. This is the hard link, and the best way to think of it is as a file's direct twin.
And creating one? It's incredibly simple. You just use the ln command, which, you guessed it, stands for link, followed by the original file and then the new file name you want to create. That's it. No special flags, just ln, source, destination.
So what's actually happening under the hood here? Well, you're not making a copy. You're not duplicating any data. All you're doing is creating a second file name that points directly to the exact same inode. It's literally two different names for one single set of data.
And hey, you don't have to take my word for it. You can easily prove this. Just run the ls-i command. That little -i flag tells it to show the inode number. And what you'll see is that both original file txt and hardlink file txt have the exact same inode number. They aren't just similar, they're pointing to the same core identity.
So to wrap up hard links, they share the same inode. This is huge because it means if you delete the original file name, the data is totally safe. The second file name is still pointing to it. The system only actually deletes the data when the link count to that inode hits 0. But there are a couple of important gotchas. You can't create hard links across different file systems or drives, and you can't use them for directories.
Okay, so that's the hard link. Now let's switch gears and talk about a more flexible and probably more common approach, the symbolic link. You'll also hear it called a soft link. Instead of a twin, I want you to think of this one as a signpost.
Creating a symbolic link looks almost identical to a hard link, but with one absolutely crucial difference. You add the -s flag. That S stands for symbolic, and it completely changes how the link behaves. And here's where it gets really different. A symbolic link doesn't point to the inode. No, instead it points to the other file's name or its path. It's basically a shortcut that just says, hey, the file you're looking for, it's over there.
Now, if we inspect these with that same ls-i command, we see two really telling things. First, notice they have different inode numbers. That's because a symbolic link is its own separate tiny file. And second, you can see that little arrow, which literally shows you that softlinkfile.txt is pointing to the path of original sfile.txt.
So the key traits for symbolic links are almost the mere opposite of hard links. They have different inodes, they point to a path, not the data, and this is the big one. If you delete the original file, the symbolic link breaks. It becomes a stale or dead link that points to absolutely nothing. But on the bright side, because it's just a path, it can point to files on completely different hard drives or partitions, which is super useful. Okay, so we've got two powerful tools in our toolkit. But how do you actually decide which one to use and when? Let's put them side by side. This table really makes it clear, doesn't it? If you need a resilient link where the data sticks around even if one name gets deleted, you want a hard link. But if you need a flexible shortcut that can point across different drives or to a directory, then a symbolic link is your go-to. It really just boils down to whether you need to link to the data itself or just to its location. Now, this isn't just theory. Links are used constantly in real-world Linux systems. Let's look at a few practical places where you'll see them in the wild. A classic example is version management. A generic command like Java is often just a symbolic link pointing to whatever specific version is installed, like Java 17. When you update Java, you just change where the link points, and all your scripts keep working.
Hard links are great for quick space-saving backups. If you accidentally RM the original file name, the hard link is still there, protecting the data. And you'll often find commands like mkfs.x3 and mkfs.x4 are actually just hard links to the very same program, which saves a little disk space.
Now for a quick but really important word of warning, especially with symbolic links. A broken or stale link can be a genuine security risk. Imagine a soft link pointing to a file that gets deleted. An attacker could potentially swoop in and create a malicious file with that exact same name. Now your system thinks it's running a trusted program, but it's not. So always be mindful of where your symbolic links are pointing.
So if you remember just one thing from all this, let it be this simple idea. A hard link is a second name for the same data. A symbolic link is just a shortcut to a file's location. And that's pretty much the whole story. We've seen that links are a really clever way to manage files without wasting space or creating confusion. So the question I'll leave you with is, now that you know the difference, where in your own projects or your own system could a well-placed link make your life just a little bit easier? Thanks for tuning in.